from Group Ace from 5 ABM1.
In this video, we're going to explain about the VOR
and Localizer.
I will explain about the VHF radio range. VHF is a type of short-range radio navigation system for aircraft, enabling aircraft to determine their position and stay on course by receiving radio signals transmitted by a network of fixed ground radio beacons. It uses radio frequencies in the VHF band from 108 to 117.95 MHz. The principle of VOR operation is based on the generation of radios or magnetic bearings by a ground station transmitter and their reception by an airborne receiver. Dah biar.
I will explain about how the VOR station operate. Okay, VOR station operate in VHF frequency range from 108.00 until 117.95 MHz. VOR stations are identified by transmission at 3-letter Morse code sent 10 times each minute. Okay, a pilot determines VOR station. First, select the frequency desired station. Then, turning the Omni Bearing Selector or OBS until the course deviation indicator CDI centers. The reading on the OBS will indicate it regardless of its heading. Lastly, the arrow is provided on CDI to determine if the information is unusable. Okay.
VOR and Localizer portion of the instrument landing system operate in the same frequency range. One VHF navigation receiver is used for both functions. Usually, the VOR and Localizer circuitry will be found in the same chassis as the VHF navigation receiver. VOR navigation concepts based on detection of two distinct signals contained within one carrier signal transmit from a VOR ground. Second, comparing the phase difference between them to derive the bearing from the station. The VOR circuitry derives to or from bearing information and left or right deviation by comparing the received bearing with the setting of the Omni Bearing Selector. An aircraft flying inbound to a VOR station on the 260-degree radial requires the pilot to slew the OBS to the 80-degree magnetic course setting. Thank you.
My friend have explained to you about VOR, and now I will explain to you about Localizer. The first thing I will explain is the principle of Localizer. It is located 1,000 feet from the end of the runway, offset 300 feet from the runway certain line, and it has a horizontally polarized antenna array. The VHF frequency range of 108.10 MHz to 111.95 MHz, identified by the transmission of a 4-letter identification code modulated at 1020 Hz and also by voice identification. The localizer station radiates a beam of information indicating the horizontal centerline of the runway. This beam is produced by two transmitters operating on the same channel frequency and amplitude modulated with different audio signals, which are 90 Hz and 150 Hz. The transmitting antennas are aligned to radiated two lobes that intersect the runway centerline. Viewed from the approach end of the runway, the 150 Hz modulated lobe is on the right and the 90 Hz lobe is on the left.
Now, my friend just explained a little bit about the principles of Localizer. Now, I will explain briefly about the principle of Localizer. When the aircraft approaches the runway, the navigation receiver demodulates the received signal, and the localizer instrumentation unit compares the amplitude of the 90 Hz and 150 Hz signal levels, provide a deviation signal output to the CDI, which is proportional to the balance or unbalance of the 90 Hz and 150 Hz signal. The aircraft is centered with the runway when the 90 Hz and 150 Hz localizer signals are equal in amplitude as indicated by the zero diffraction of left or right needle on CDI. Next, I will explain about the localizer circuit theory. Typical airborne localizer instrumentation circuit utilize the same VHF receiver that is used for VOR navigation. In some cases, a common VHF receiver opening in the frequency range of 108 to 135.975 MHz is used for first VHF communication 118 to 135.975 MHz. Then VOR navigation 108 to 117.950 MHz. And last one, localizer operation 108 to 111.950 MHz. That's all.
Hope you have understand what we have explained to you.
Thank you.